This example is just going to briefly explain how we find the sums of squares totals for a one-factor ANOVA table. The first thing we need when we're calculating the sums of squares totals is we need our sums of squares. To do that, we need to square every value in the table and add them together. Using the Casio ClassWiz, the quickest way to do that is to use the statistics option. So menu, scroll down to number 6, statistics, and one variable, type in all the data as one variable. So I'm going to type in 12 equals 13 equals 12 equals 15 equals 21 equals 19 equals 18 equals 20 equals 16 equals 17 equals and 15 equals. If I then clear the screen and go to my options OPTN and 2 one variable calculations, I can see I have a sums of squares option. So looking on my calculator, I can see that my sums of squares value is 2978. Now I have my sums of squares, I can calculate some of the other sums of squares options. The first one to calculate, which is also the first one in the formula booklet as they come in order, is the sums of squares total. And that formula is given as the value we've just calculated minus all the x values added together squared over n. So using the values we've just calculated, that would be 2978 minus, and again if I just look on my calculator here, I have a sum of x value which is 178, so I'm going to use that, squared over n. Now n's quite nice and easy, I can just add up how many numbers I've got, but in case I want to just double check, I can again scroll down to my calculator and see here that n is 11. I can then put all of that into my calculator to get an answer. So if I go back to menu and just go back to number 1, calculate, and I can put this all in as one sum. 2978 minus, then I'm going to use my fraction button, 178 squared over 11 and equals, and let's not leave it as a fraction, let's have it as a nice value, 97.636. I'm going to do a few extra decimal places here so that I'm more accurate later on in the question. So our next calculation is the sums of squares between, and from the formula we have the sum of each column total squared over how many are in that column total, and we do that for each one. And then we subtract the same thing again, so we subtract the sums of x all squared over the total value of n. So what I need to do is I need to work out the total first of all for each group. So I'm going to do 12, add 13, oops and daisy, add 12, add 15. So my first column, this column here, adds up to 52. So in my formula I'm going to do 52 squared over, and I can clearly see there's 4 numbers in that column. Then I'm going to do the same for the second column. So 21, add 19, add 18, add 20. And that column there adds up to 78. So that's going to be 78 squared. And again, there's 4 in that column. For the final column, I'm going to do 16, add 17, add 15, and that gives me 48. So that's going to be 48 squared, but this time that's going to be over 3, because there's only 3 numbers. Then just remembering from our previous calculation, this here is going to be 178 squared, because that's what all of those 11 numbers add up to, divided by 11. And I'm going to put that all in my calculator as one big sum. So start with my fraction bracket and then my fraction. I'm going to do 52 squared over 4, add fraction, 78 squared over 4, add fraction, 48 squared over 3, and then I'm going to close that bracket, and then I'm going to minus my other fraction of 178 squared over 11. And that gives me, if I turn it into a decimal, 84.636. And again, I've done just a few extra decimal places there, just to make sure that I'm not rounding too much. So my final sums of squares is the sums of squares within. And this is quite a nice simple one to do because it's just what's left. So I'm going to do my sums of squares total, take away my sums of squares between. And this is why it's always important to check that your between is less than your total value, because you shouldn't have a negative answer. Okay, so thinking back then to our sums of squares total, we had that as 97.636. So 97.636. And for our betweens value, we had 84.636. And I can clearly see my decimals are going to cancel out here. So 97.636 take away 84.636, and that gives me my sums of squares within to be 13. And that's just a brief video showing you an example of how to find your sums of squares values for a one-way and over table.